Hello! In this section we are going to discuss thin layer chromatography or TLC. TLC is the type of chromatography in which the stationary phase is spread on a sheet, planar chromatography. TLC is a planar chromatographic technique in which the stationary phase is spread on a sheet. It is used for the separation of a mixture of compounds in which the chromatographic system consists of a mobile phase or solvent or eluent, which is usually an organic solvent, and a stationary phase such as silica gel or alumina, which is held on a support such as glass or aluminum sheet. The applications of TLC in pharmacopoeial monographs is for the identification of drug substances and or to check the purity of drug substances. Okay, so what is the main concept of the chromatographic separation? If a mixture or the sample, unknown sample, flows in a mobile phase, which is usually an organic solvent, over a material which is the stationary phase, the sample has different affinities to the mobile phase and the stationary phase. The sample dissolves and its components, the different components present in the sample has different solubilities either in the mobile phase and the stationary phase. And due to this interaction, the stationary phase will retain some components more than others. So different components will flow over the stationary phase at different speeds or rates. The main feature of all chromatographic techniques is the use of two main components. One, the mobile phase, which could be either liquid or a gas, and a stationary phase, which is usually silica or aluminium. The stationary phase is usually a powder, which cannot be used as such. It cannot be used as a powder. You cannot apply the sample onto a powder. So the powder could be either spread onto a glass or an aluminium sheet, and hence it will be called thin layer chromatography, as a thin layer of the stationary phase is spread onto either a glass or an aluminium sheet. Okay? This type of chromatography will be discussed further in another section. The second type is when the powder's stationary phase is packed into a column, and hence this type of chromatography is known as column chromatography. So TLC is a type of planar chromatography, as the stationary phase is on a plane. Okay, and the other type is column chromatography, in which the stationary phase is either packed onto a column, such as the burette, and we will show you how this is done, or it can be packed onto a column, a stainless steel column, as is the case in HPLC, high performance liquid chromatography. This instrument will be discussed further in the lectures. So in this section, you are going to perform a chromatographic separation of a mixture of two acid-base indicator dyes, which are eosine and fluorescein. The aim of this experiment is to verify the identity of each dye. Okay, so what are the materials that you are going to need in order to perform a TLC experiment? First of all, a TLC plate. When you buy a TLC plate, it has the shape of a square. Okay, it's big and it has the shape of the square. But such big plate or sheet, you won't be able to put it in a glass jar. So in order to be able to put it in a glass jar, we cut it into smaller parts, each 2.5 centimeters. And in this shape and in this size, you will be able to place it easily in the glass jar. So when you're in the section, you will be given this sheet and not this sheet. Okay? Next thing is you should have a ruler and a pencil. I repeat, only pencil. Never use a pen. Why? Because pen contains dyes which will dissolve in the mobile phase. These dyes are soluble and will be able to dissolve in the mobile phase and disturb the separation procedure. Also, in order to apply the spots, we use capillary tubes in which the solution rises up the capillary tubes by the action of capillarity. These are the capillary tubes, and these tubes you will be given. Okay, next thing, you will be given a standard solutions of two acid-base indicator dyes. The first is methyl red and the second is fluorescein. Also, you will be given a mixture solution containing both methyl red and fluorescein. Also, you will be given a mobile phase or eluent that will be placed in the glass jar, TLC jar also. So for your knowledge, if the solutions that you're using and spotting on a TLC plate are uncolored, you will need to have a UV cabinet in order to be able to visualize the spots. In this section, you will be given colored dyes, so we're not going to need the UV cabinet. But for your information, if you are using uncolored solutions, you should have a UV cabinet to be able to visualize these spots. Okay, let's go to the practical steps in order to perform this experiment. Okay, procedure. First, pour 5 milliliters of the mobile phase into the developing jar to yield a depth of just less than 0.5 centimeters. Then, in order to allow the gases to reach equilibrium, cover the developing jar with its cover very quickly and swirl it gently and allow it to stand for a while until you prepare your TLC plate. You should not move the developing jar during this step. Then, carefully handle the TLC plate so that you do not disturb the coating of adsorbent or get it dirty. Your hands should be very clean, and any disturbance to the coating of the adsorbent will ruin the whole experiment. So please, as the TLC plates are very delicate, you should be super cautious while handling it. Then, measure 1 centimeter from the bottom of the plate. Draw very gently a line, which is the starting line, across the plate using a dull pencil, which is not very sharpened, on the side that has the silica. If you push it too hard, you will scratch off the silica, and you don't want to do that. So again, be very careful. Then, leave 0.5 centimeters from the side, mark the space of one spot for methyl red. Then, leave 0.5 centimeters and mark the space of the second spot, F, for fluorescein. And then leave another 0.5 centimeters and mark M for mixture. Okay, then, dip a clean capillary tube into the standard solution to draw up about 1 to 2 centimeters of the solution. Touch the end of the capillary onto the TLC plate at the point designated for the methyl red. Be careful, do not disturb the silica layer. When a small amount of the solution comes out, remove the capillary to get the smallest spots possible. You have to touch the TLC plate briefly and to only get a small spot. You can rehearse or maybe try spotting from the capillary tube onto a tissue paper before spotting onto the TLC plate. So bring a tissue paper, add the spots using a capillary tube onto the tissue paper, and until you get the smallest spot possible, then you have control of the amount you are releasing from the capillary tube. Then you're ready to spot onto the TLC plate. The spot you should be adding onto the TLC plate should be the smallest spot possible. Then let the spot dry. You can repeat the spotting after drying, which means double spotting. Okay? This step is very critical. Then the amount of solution you're releasing from the capillary tube should be controlled, and this can be only done if you rehearse or make several trials on a tissue paper before trying to spot on the TLC plate. If you get a large spot, this means that the spot will be tailed and it will not be circular and it will be asymmetric, and you don't want to get this type of spot. Okay, as you can see here, an ideal spot is very small and circular. As you increase the amount of solution released from the capillary, you get a larger spot and it's a bit tailed. This is not very good, okay? You don't want to get this look on your TLC plate. Okay, then repeat steps 6 and 7 for fluorescein and the mixture. Place the prepared TLC plate in the developing jar and then cover the jar and leave it undisturbed. Do not move it. Do not move it. The solvent will rise up the TLC plate by capillary action and then will separate the dyes. Then allow the plate to develop until the solvent is about ½ centimeter below the top of the plate. Then remove the plate from the beaker and immediately mark the solvent front with a pencil. Leave the plate on a paper towel or a tissue paper until it's completely dry. Measure the distance traveled by each spot and by the solvent. And then, finally, calculate the RF values for each methyl red, fluorescein, and the mixture.